Welcome to Secret Messages. So for this Python project, we are going to learn about encryption, hiding information, and decryption, unlocking information so that we understand what a message is. An example of this is if I type a message simply, such as hello over here, and I type a shift key, like 4, the hello gets encrypted to a secret word. And then if we figure out the right way to decrypt it, we'll be able to type in LIPPS and get back as a result the word hello. You'll notice LIPPS, if I type that with the same code, we don't get back hello, so we'll have to figure that in the project. So first thing we need to know is when we are going to go on to the next step, you're going to need a Python Trinket to run. So first thing you should do is make sure you have an account. I made a video, go check that one if you haven't watched it. And then just go to trinket.io. And you're going to go ahead after you've already logged in. You're going to go into My Trinkets, and you're going to add a new Python Trinket over here. This Python Trinket, make sure you title it Secret Messages, and you're going to start by writing over here this statement to make sure that we're using Python 3 over here. So you can copy and paste it in, or you can go ahead and type that statement in. Once we have this, we are ready to go, and you'll see that I prepared it right over here. So next thing is we're going to go on to the second step, the Caesar Cipher. This is going to teach you guys about how we encrypt that information. A cipher is a type of secret code that swaps letters around so no one can read the message. And we're going to be using one of the oldest and most famous ones, the Caesar Cipher, which is named after Julius Caesar, which, if you don't know the guy, is a Roman general, very famous guy who led Rome over here. You can look him up if you want, but the Caesar Cipher over here is going to hide a word with encryption. To do that, we have to lay out all of the letters in a circle, all 26 of them, and we are going to then hide a letter by making kind of a shift a couple places, 1, 2, 3, or however many places to the right over here. So in order to encrypt a letter, we need to move 3 letters clockwise. So if we set a key to 3, what's going to happen is H plus 3 letters is 1, 2, 3 places away, gets us K. We have the original word hello, Hello, and every letter plus 3 gets the word cohort over here. Getting the text back to normal is called decryption, and decryption is just subtracting the key instead of adding to it. So if we have the word cohort and we subtract 3 to each letter, we get back to hello. So the key to decryption is finding the right key in order to get the word back to the normal word. So to use the secret cipher over here, what we're going to do is we're going to open that trinket as I just said, and you're going to want to split your screen. So I'm going to have right here the instructions on how to encrypt letters on the left-hand side of my screen. So I'm going to drag this over to the left, and then I'm going to take my code over here, and I'm going to drag this over to the right-hand side of my screen. If you want an easy keyboard shortcut, just hold Windows right, and that'll pop to the right over there. All right, so let's get started with our instruction secret messages. First thing we're going to do is instead of writing the alphabet in a circle, we're going to write it as a variable over here. So we're going to set in a variable alphabet is equal to the string A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. If you can do that without looking, that'll be very impressive. All right, so we have this string over here, alphabets. And each letter of the alphabet has a positioning just like it would in the cipher. And what we can do is, we're not going to need this in the long run, but if you write print and we call alphabet, and we're looking, if we put a bracket over here and we say 0, it's going to ask us what's the 0th term of this. So if we run this, it's going to say A, because it's the very first, in other words, the 0th thing in the list. If I print this again and I say what's the second term over here, it's going to say C. So really it's the third term, but 0 is included. What's the 5th term? So it's going to tell you what letter of the alphabet that is. We don't necessarily need this command, but you can go ahead and try it out and play with a bunch of them just to see what letter of the alphabet it is. Next, we're going to need to create a key in order to store whatever amount we're going to be shifting away. So this example gives you a key of 3. You can choose the key of anything. I'm going to do 3 just to stay consistent with the example over here. Next, use the user for a single letter called character in order to encrypt. So this is going to create a single character that we're going to encrypt. So we say character. So we're creating the variable character, and we're going to ask for user input. and we're going to ask for the user to type something into the code editor and then hit enter. So what we're going to ask over here, the question is, please enter a character, colon, space, apostrophe. All right, so if I run this over here and I enter the character A, nothing's going to happen yet because I haven't asked anything to happen yet. But that's where we're going to be able to enter it over here. So next up, after character, we are going to find the position of that character. So we're going to use that by creating another variable called position. And we're going to set that equal to the alphabet. And we're going to say find character over here, the placements of it. We can now test the stored position by printing it. So we'll create a print command, print over here, and we're just going to print out whatever that position is. And the way that we're finding the position is based off of where in the list that it is over here. So if we print position and we type the letter A, it's going to print 0. If we do it again, we print G, it'll print 6, as it is the 7th letter of the alphabet in the list over here. Next up, after we print that, we are going to encrypt the character with the key. So I set the key over here to 3, and then we're going to use that and create a new variable called new position, which is just going to be the old position plus the key over here. So let's set new position equal to the position plus the key over here. So if my position over here is the letter A, in other words 0 plus 3, it'll move 3 places to the right over here. And then if we print the new position, we're going to go ahead and see that. So if I enter the letter G, it'll be the 7th letter of the alphabet, and it will then shift to become the 9th letter, so the G will change letters over here. So in order to see that letter get changed, what we're going to end up doing is we're going to, well, in a second, I forgot this part. So what happens if you enter something too late in the alphabet? Like if I say the letter Z, there's no 28 letters in the alphabet, so we're going to have to create a tool to deal with that. And that tool is called the modulus function over here. So modulus is kind of like the percent sign, and it's going to help us tell the new position to go back to 0 once it gets back to position 26. And the best way to explain this is if you have the number 7 and you divided that number by 3, that's really the number 2 remainder 1. So the remainder is basically what the modulus is looking for. So this is of the 26 letters. When we have remainders, those remainders will go back to the starting position. So what we're going to do in order to make sure that it shifts all the way around the alphabet is we're going to set over here the new position to, and we're going to modify this line over here, line number 13. We're going to say that new position is the position plus the key. Also, modulus 26 to state that everything after 26 should go back to look at 1, 2, 3, 4, 5, 6, and so on over here. So if we run this again and we type Z, and the shift is still 3, so we'll go from the last letter of the alphabet 3 places to the 2nd letter. So that Z is going to become a C, although we don't see that yet, so that'll be the next thing we have to do. So for adding letter 7, yeah, that sounds good. So what we have to do over here is we're going to create a new character over here. In other words, what is the shifted place going to be? So new character is equal to alphabet, parentheses, new position. So we can create that character and we'll print what that new character is going to be over here. So let's go ahead and run this. If we enter the character over here, F over here is starting on place 5, moving to place 8, and at place 8, it is the letter I. If we run it again and we type the letter Z, it shifts over to become the letter C, as I mentioned before. If I do the letter A, it'll shift 3 places and become the letter D. So now that we kind of were able to encode a character and get a new letter as a result of it, let's go on and go over to the variable keys over here. So our goal is now to modify the program so that the user can enter their own key. It doesn't have to be a key of 3, where they can choose how much it wants to shift over here. So to do that, what we're going to do is we want to, well, first off, make sure that your code looks like this over here. First thing is we are going to add to the print command of new character. We're going to state over here, we're going to create a string the new character is :end string, comma, new character. That's just going to say over here, if I type A, it's going to tell us not just the character, but it's stating that our new character is the letter D, so that we know what's going on. And now we're going to create a variable to store the new encrypted message over here. So under our key, what we're going to write is we're going to write new message is equal to parentheses, apostrophe. They're going to change the code to store the user's message in not just one character. So under new message, instead of just storing the character, we're going to change this variable to be called message, MESSAGE, and that's equal to inputs. Please enter not just a single character, but enter a message. And then we're going to add a for loop to our code and indent the rest so it's repeated for each character in the message. So before we do over here position, we're going to say for character in message. So let me just break down what that means for a second. So for character over here is going to be our variable, and message over here is going to be what the user inputs over here that will be stored and reused over here. So we are going to then take the new position commands, position, new character, and print. So position, we don't need to print position anymore. So I'm going to comment this out for the time being. New position, we need print new position. We are going to print new character. So we no longer need this statement inside of our loop over here. And new character, alphabet, new position, print the new character is. So we are only printing over here what the new character is. We don't need to print these two statements, which is what I had just commented out. So the next time we run it, it's only going to, we have to indent this first, but it's going to let us only see the end results. So if I highlight all of this and I indent this, you can see that that's aligned at like a level 1. I'm going to hit tab to align all of that. And now if I click run over here and I enter a message like hello, it's going to say the new characters for each individual letter is KHOR. And it's repeating over here all of the statements for each of the letters. So if I type a 5-letter word, it repeats 1, 2, 3, 4, 5 times, and it will tell me what the new character is for the entire message over here. And we can see that it's printed line by line. And now we're going to add each character to my new message variable over here. So down below the print, I'm going to type new message, and we're going to use a new type called plus equals new character. So what that's going to do is every single repeat of the code, it's going to add the previous character to the second one. So if I run this over here and I type hello, you're going to notice over here, I need one more thing. I need to print the new message over here because that's my new variable. So print new message. So if I run this, I'm going to then, if I type hello, it'll write the new character is K, KH, KHO, KHOO, KHR. So it's the symbol over here is adding the previous letter to the original word over here until we get the full word over here. If we delete the spaces before the print, it will only be displayed once over here. So if I comment out this sentence, this print command over here, and then I run it because I still have print new message, and I type hello, it will just give me all of the letters over here. And then if I don't want all of the letters, I can take the print command outside of the loop, so it only happens once. And if I write hello, it should just give me the new encrypted word over here. If I want to include your new message over here, is we can print beforehand that string, parentheses, your new message is apostrophe, comma, new message. So if I write one last time, hello, my new message is Cahor over here, and using the key of 3. If I shift my key up to 4, it'll be a little different. So hello shift 4 places, and now it's the word lips over here. So how do we add extra characters? Because right now, if I were to type hello, exclamation mark turns into a C. And maybe I don't want that C to be also encrypted. I only want the words. I want the exclamation mark to stay. So how do I do that? How do I keep those extra characters without getting rid of them over here. So some characters aren't in the alphabet. That causes an error. Some characters, so to test your code out, we saw with the exclamation mark that it turns into a C because that's still getting shifted. So we don't want that to happen. To fix it, we only want to translate a character if it's in the alphabet. And to do this, we're going to add an if statement to our code and then indent the rest of the code over here. So in that loop for character and message, what we're going to say is we're going to say if the character is in alphabet, which we defined up above as those 26 letters. So if it's in alphabet, do all of this. And then if it's not an alphabet, it won't be doing all of that. And I'm just going to get rid of these print commands because we no longer are using these. We've replaced them. Print, just so the code's a little easier to read. Character. And then over here, it would be better if your code didn't encrypt anything else. Add an else statement to your code, which just adds the original character to the message. So over here, we have if it's in the alphabet, do all of that. And then go back, I'll indent line so that the if lines up with the else. And then we have colon, new message plus equals character. Not just new character, but plus equals just the original character over here. So let's give this a run and let's see what happens. If I write hello, exclamation mark, my new messages cohort over here, and we remain these being exclamation marks, something that we did not want to encrypt. So any character left is encrypted, but the other characters were left alone over here. So that was a bit lengthy, longer on a normal video, but this was how to encrypt a secret message. The challenge that you guys can then continue to work on beyond this video is trying to give some sort of encrypted message, not just the word hello, but maybe you say over here, I am in period 3 in computer app life. And then you run that, and then you try and get your friend over here to encrypt or decrypt this encrypted message over here. Hopefully this was a helpful video. I look forward to you guys doing this challenge. And if you want then to keep going, they have an extra challenge over here, which you guys can do, not required for me though. So enjoy, see you guys in the next video.